All right, folks, we need to practice two different kinds of calculations regarding waves. Let's make a graphic organizer together. You can do this in your notebook, if you have a science journal, blank piece of paper, but let's do this together because we need to practice the difference between calculating wave speed, which is how fast or slow a wave goes. That's not exactly frequency, it's called wave speed, or how much energy it has. Even if you don't end up in a career where you are building technology, it's helpful to understand these for when you are buying technology. Wave speed is a function of frequency and wavelength. Notice I'm saying a function of. In science, that means there's some mathematical relationship between them. We don't know exactly what they are yet, but we will figure that out. But energy is only a function of a wave's amplitude, how big it is. Okay? How fast it is, how big it is. So let's do an example. Let's do a wave. Okay. Let's say its frequency, which I can't quite show you because you don't see the movement of how squished it is together. Let's say it's 4 hertz. Hertz Hz is the unit of measure for frequency. And let's say the wavelength you can measure from point to point, crest to crest, trough to trough, doesn't matter. Let's say the wavelength is 5, and we'll use metric system for now, 5 centimeters. Okay, so if wave speed is how fast or slow it goes, then it's the frequency times the wavelength because it's how smushed together it is versus how long it is. So you multiply those and you're going to get 20. And even though it says hertz times centimeters, when we refer to wave speed, we refer to them as centimeters per second. Eventually, you're going to learn a new symbol called lambda. It's a Greek symbol, relationship in waves. But for now, we would just say 20 centimeters per second is how fast this wave is moving along, which is not that fast, given what I understand about cell phones and radios having much higher frequencies. Amplitude has a formula of amplitude squared to refer to how much energy is in this wave to begin with. Is it a very powerful wave or not very powerful wave? So let's say its amplitude is from here to here. Let's call that, I don't know, 3 centimeters. So it'd be 3 squared, which is 3 times 3, or 9. And it's, when we're referring to waves, we don't use centimeters squared for that unit. We change it to the unit of energy, which is 9 kilowatts. So this one tells me how much energy is in the system. 9 kilowatts is referring to how much energy is capable of this wave pushing through versus how fast it's going. Okay, so it's nice to be able to use two different ways to refer to how big or small and how fast and how much energy are in the different waves.